Okay, this lesson is on graphing basic logarithms, and we're going to use mostly the idea of inverse functions here to generate the graph of a logarithm. So let's recall, we said earlier if f of x is 2 to the x power, then let's make a better x, there it is, 2 to the x power, then the inverse of 2 to the x, what a logarithm is, again, it undoes a exponential function. So the inverse function of 2 to the x is log base 2 of x. And if we recall how the graph of 2 to the x looks like, goes to the point 0, 1, 1, 2, 2, 4, 3, 8. Where's 3, 8? Somewhere up here. And lastly, 4, 16. That's up here. No, it's all the way up there. And likewise, it's negative 1, 1/2, negative 2, 1/4, negative 3, 1/8, and so on and so forth. So this, again, was, I just totally missed it. It's so hard to do. This is close enough. The graph of 2 to the x. Y equals 2 to the x power. We have an asymptote over here, and in fact for 2 to the x, I'll leave this color here. The domain, we said, was all real numbers, negative infinity to infinity, and the range was, or is, 0 to infinity, not including 0, because we for any value of x we put in there, we're always going to get some number out of it, except for 0. 2 to any power will never be 0. So let's use the reflection principle here of inverses. That is, if we have the line y equals x, so it's the 45-degree line right here in blue, we said that the inverse of a function is a reflection about the origin. So, in other words, if I know some critical points that are on y equals 2 to the x, like this point 0, 1, what does that mean is going to be on the inverse function log of 2x? You guys are so smart. Good. The point 1, 0. And you can kind of consider this the critical point of the logarithm. Now you notice what else happens here. You notice out here we said as x goes to negative infinity, y goes to 0. So as x goes to negative infinity, y goes to 0. And the cool thing is, for inverse functions, guess what that means for the logarithm? I could just flip those two. So as x goes to 0, in this case from the left, y is going to go to negative infinity. What's going on? I'm stuck. Hey. Oh, there it goes. Okay. Y goes to negative infinity. So what does that mean? This region on the left of y equals 2x that I had circled is going to correspond to, let me pick a new color, not this dark green. Which color should I choose? Magenta? You want me to choose magenta? Fine, I'll choose magenta. So this side here of the log is going to be an asymptote, and here it's getting closer and closer to the y-axis as opposed to the x-axis. Okay, well let's pick a few other points that I said were on this y equals 2 to the x. We said the point 1, 2 is on there. 1, 2 is on there, so guess what? 2, 1 is on the logarithm. And the point 2, 4 is on y equals 2 to the x, so the point 4, 2 is on the log of x. And as is the point 8, 3. And again, this is going to be a reflection about that blue line, y equals x, that I drew on there. And look at that. What is wrong with my stylus today? Y equals x. And can you see how that's a nice mirror reflection of the line, about the line y equals x? I knew you could. So this is our basic logarithm graph here. And notice something here. Was this an exponential growth or decay problem? Which one? Good, growth. So let's just see what happens. Last graph here. Let's start a new screen. And let's see what happens if we choose an exponential decay function. Let me make my y-axis and my x-axis. Hold on, I'm going to undo that. That wasn't good. That's better. So let's choose another function here. Let's say that f of x is, let's use the halving function, 1/2 to the x power. What about if f inverse, so what's the inverse function of this going to be? Log of 1/2 to the log base 1/2 of x. So hopefully we remember how the graph of 1/2 to the x looks like. It's just a simple reflection of the last graph that we had, and we're still going. I should pick some points before I draw that. We're still going through the point 0, 1 because 1/2 to the 0 power is 1. But now when x is 1, y is going to be 1/2. When x is 2, it's going to be 1/4, 1/8. Vice versa, when x is -1, and again we're doing f of x here. When x is -1, we have 1/2 to the -1 power. The reciprocal, if you will, of 1/2 is 2, and then it's going to be 4, and then we learned this before, 8, and so on. So this is our, it could still, okay, I gotta do this better. So this is going to be the graph of 1/2 to the x power. So let's go back and just use that reflection property. Let's see what happens. Here's the line y equals x, and let's just try a mirror image here. So check it. We said here as x goes to, if you look here, as x goes to infinity, y goes to 0. So guess what? R, and that was of our original function. So I got to flip-flop those two again for my inverse function. So as x goes to 0, in this case from the positive side, y goes to positive infinity. So we're going to look like we're going to have some kind of asymptote here on the y-axis instead of the x-axis. Okay, again, let's pick a few points. Well, still the point 0, 1 is on our regular function, so we know the point 1, 0 right there is going to be on our inverse function. Let's see, what else do we got here? We had this point, for instance, was -2, 4, which guess what? That means that the point 4, -2 is going to be on my inverse function. And if I wanted to pick this point over here was -3, 8, so guess what? 8, -3, it's right there. Right there. Yeah. So I'm going to erase this part here because it looks bad. So if you see here, what color should I choose this time? Yellow? No, yellow's not going to work. You're not going to see yellow that well. What? Give me another color. Orange. Great idea. It looks a little too much like the red that we have up there. Bad idea. Let's pick another one. Purple. Okay, purple. Okay, so we said we have an asymptote here, and we have a logarithm. The graph of the log is going to go this way. So let's just look at our basic two logarithms. If our base is greater than 1, like we had in this case, we had log base 2, we're going to get this kind of shape. And if our base was less than was less than 1, somewhere between 0 and 1, we had the opposite shape this way. And everything else, I think you could figure out for the graphing for our homework. So good luck.